Hello everyone, welcome to the channel Chemical Engineer. Myself Sahil Yadav, and in this video we are going to see about P&IDs. So what are P&IDs and what are the different symbols that we are going to use to create a P&ID? So all those things we are going to see in this lecture. If you are new to this channel, please subscribe to the channel. So let us begin with the P&ID. So the full form of P&ID that we say is a piping and instrumentation diagram. So it is also known as PEFS, Process Engineering Flow Scheme. In various countries, they are using PEFS as an alternative of P&ID. So what is it? So P&ID is a detailed schematic diagram that shows the complete piping, instrumentation, and control system of a process plant. So if you are having some a refinery or something a plant, then to describe the process fully, which includes all the pipes, all the instruments, all the control systems of it, as well as equipments. So that diagram is known as P and ID. So let us see what actually it includes. So P&ID includes all major and minor equipments, any equipment that we have established in our plant are included in P&ID. So it will include pumps, vessels, columns, reactors, compressors, then we can say valves and all other things like that. Then it will include instruments like pressure indicator, level indicator, temperature indicator, flow meter, pressure transmitter, level transmitter, temperature transmitter, and all other instrument things. It will also include valves as well as actuators. So actuators are nothing but the instrument which controls the valve. Okay, so this should be clear in your mind. Moreover, it will include utilities and process line. So the pipes that we are getting for crude to the final product, that all things are included in P&ID along with the specifications. Specification means suppose if you are having a pipe of 25 mm, then it will be mentioned on the P&ID diagram that this pipeline is a size of 25 mm. Okay. So all those things are included in P and ID diagram. What are its uses? So they are used to locate the valves, pipes and control valve. So P and ID we can say it is a drawing which we can see of our actual plant. Actual means physical plant in a field. So for that thing we are making a P and ID and we can refer it to know the exact location of any valve, pipe or any control valve. Okay. It can be also used for maintenance and modification of the process. You can do only modification if you know that it's P&ID. It's P&ID means if you are suppose doing a modification of a control valve, if you want to replace a control valve, then what will you do? You will first analyze that where that valve is present in P&ID. Suppose you find that valve is present. Now you will what will you check? You will check whether this valve is connected with any other process. So in P&ID, suppose if it is connected, then dotted lines are used. Suppose it will be connected to some flow meter. Alright, so this is a flow meter. Suppose it will be if both are connected, then this dotted line will help us to identify that the connected thing, if we remove this valve, will also be affected. All right. So for maintenance and other purpose also they can use P&ID. Mechanical technician and safety personnel. For safety personnel, it is very important to understand the P&ID. Why? because without P&ID, a safety cannot do any task in a process. Suppose if they want to change some reactor. Now, if you want to change any reactor, what will you require? You will require to remove all the pipes connected to it. So, to determine which pipes are connected to it, you have to go through the P&ID. So, for any safety concern related issues, you can refer P&ID. For optimization in plants, so if you are equipped with the new technology, then it's not required. But if your process plant is using old technology and you want to do optimization in a plant, then you require old P&ID, and then you can use a newer P&ID to determine which things which we can replace can optimize the process. All right. So these are the uses of P&ID. Now let us see some examples or symbols that we are going to use in our subsequent lectures to make a P&ID. Suppose you are having a gate valve, then it will be drawn as a this simple V type or a sand clock type structure. Then it will be a gate valve. If suppose a dark black circle is given in the bottom, then it will become a globe valve. If suppose a ball is present in the bottom of that gate valve, then it will become a ball valve. Now, gate valve can be manually operated as well as pneumatic operated as well as motor or hydraulic operated. So there are different symbols of a gate valve. Suppose it is manually operated, then we can draw this handle. So it will become manually operated gate valve. If it is connected with air and it is being used for opening and closing purpose using air, then we can say it is a pneumatic gate valve. If it is controlled using motor, then we can show it like this as a motor controlled gate valve. If it is controlled using hydraulics, we can show it as a hydraulic gate valve like this. Okay. Then same applies for the globe valve. If it is pneumatic, then we show some this actuator type thing. If it is motor controlled, then we show that it is controlled by motor. This globe is controlled by a motor. This globe is controlled by a pneumatic, and this globe is controlled by a hydraulic system. Similarly for this ball valve, motor control or hydraulic control. Moreover, there are various valves like bleeder valve. So bleeder valve, you all must be knowing that they are used for removing the excess fluid or a gas present in the process. So this is a symbol of bleeder valve. The top is having a tail and the bottom is a dark black clock standing like that. Okay, so this is a bleeder valve, and you are having an angle. This is a symbol of an angle. This is a plug valve. This is motor controlled plug valve. This is manually controlled. This is plug valve. Okay, so this is all about valves. These are more valves. Needle valve, butterfly valve. The butterfly will be a gate valve plus a slanted line to show that it can be controlled various flow, variable flow, we can say. This is also a butterfly valve. This is pneumatic control. This is manual. This is pneumatic controlled, and this is motor control, or we can say this is a pressure regulator. So what it shows, this is the direction that it controls the pressure at the outlet, and this controls the pressure at the inlet. Okay. Then we have solenoid valve closed and open. How will you determine the valve is closed or open? That we will see in later section of this series. This is a diaphragm valve. These are pressure safety valves. This is a relief valve. four-way valve, three-way valve. All those are important. So you have to memorize and you have to remember that these all are the symbols that are present in P&ID. This is rotameter, this is orifice. Okay. Then to the equipments. There are various equipments. So these are the equipments. Suppose there is a tank. We can use this for a tank as well as for a vessels. Then for a mixer with a motor. This is motor and this is our mixer. So this we can say as show in a P&ID like this. Then we are having a reactor with mixer. So this is a mixer and this one is our reactor. So this is mixer reactor. Jacketed tanks. Jacketed tanks, you all must be knowing that jacket is present at the surface to heat and cool the inner surface. So this is jacketed tank. These are the agitators or stirrers we can say. This is furnace, bin, then dome top roof tank. So if it is dome, then it is dome roof tank. If it is cone, it is cone roof tank. And internal floating roof. If the roof is not fixed and floating, then it is known as internal floating roof tank. If you are having a demister pad in your column, then it is shown like this. If you are having a sparge steam or gas sparging, then it is shown like this. A sprinklers, then this is a conveyor belt. This is a centrifuge. This is a flare tower where there is a heat coming out. This is a boiler and this one is our furnace. Okay, so you have to remember all of them. Moreover, centrifugal pumps, gas blowers, compressors, gear pumps. The use of gear pump is to transport the heavy or dense slurry or fluid. These are gas compressor. Compressor means one side will be having a more area and the other side will be having a less area. So you have to say that that is a compressor. A compressor can be shown like this as also, but this is having some lobe. So this is also a compressor, but gas compressor generally is shown like this. Then we have cavity pump. We have a motor. This is also a motor that we have seen in the earlier slide also. This is compressor. Compressor is shown as a reverse of motor, but with not a base. This is a turbine or a compressor, you can say from higher area to lower area. If anything you see like compressor, then it will be going from higher area to lower area. Okay, so that is the use of compressor. Then this is a screw pump, vacuum pump with a this base showing the vacuum. Then liquid ring compressor, rotary compressor, all those things are important to remember. These are more examples. These are our screw pumps. Okay, so these are screw and reciprocating pump with motors. So they are shown like this. This is horizontal pump with motor. This is a vertical pump with motor. Vertical mounted motor is present, then it will be shown like this. Okay, and this is a caned pump, and this is a positive displacement pump which shows the two lobes. Positive displacement pumps are used when there is a high pressure requirement. Okay, now this is our last slide, and these are all our heat exchangers. Okay, so various type of heat exchangers are there. These are all our shell and tube type heat exchangers with different heads of a shell. Here the shell is having a this type of head. Here there is only one-sided marking is there, where here there are two-sided means the from two side we can open it. This is different head, straight rectangular head. This one is also the same. This one is our reboiler. Then this plate type heat exchangers can be shown in P&ID like this. Hairpin type exchangers can be shown like this. U-tube type heat exchangers can be shown like this. This one is also same like this. This is also a U-tube type heat exchanger. Okay. Then single pass heat exchanger means one side inlet and the outlet from other side. Similarly, for one side inlet for different stream and outlet at the one side, other side only. So this is single pass heat exchanger. This is our reboiler. If spiral heat exchanger is used, which is having a spiral tubes in it, then it can be shown like this. From the top view, it will be like this only. Double pipe heat exchangers. If there is air cooled heat exchanger, then we can show it like this, where the air is passing from the top of the surface. Moreover, in distillation column, in most of the industry, they are having heaters, or you can say a reboiler. Then it will be shown like this. This arrow is going down, means showing that the bottom products are getting heated. And in condenser, this shown as a top, which shows that the bottom products are top products are cooled. Okay, and these all are our shell and tube. Okay, so kindly remember all of them and take a screenshot of all of them. I have taken it from this site, so kindly I have given a reference. So please keep in mind. In next video, we are going to see how we can draw a PNID and we will see some examples of PNID. All right. Thank you very